comets and asteroids come and go, but few make as much of a stir as Oumuamua. Toward the end of last year, its virtually unprecedented appearance from interstellar space made urgent headlines around the world. And, in various ways, it left an indelible footprint. While numerous mysteries remain about this curious galactic traveler, astronomers managed to glean several key pieces of information during its recent flyby. Here are some of the most interesting. 8. It's among the fastest objects ever detected. One of the most surprising things about Oumuamua was its incredible speed. The average asteroid travels at 25 kilometers per second and the average comet at 40 kilometers per second relative to the Earth. But when Oumuamua was discovered in October 2017, it was going an impressive 60 kilometers per second relative to the Earth and only picking up speed as it approached the Sun. At its fastest, just as it slingshot around the star, it reached the blinding 87.3 kilometers per second, or 196,000 miles per hour, 315,431 kilometers per hour, relative to the Sun, which kept it from falling in completely and burning up for good. Although Oumuamua lost speed considerably as it climbed away, owing to the intense gravitational pull of the Sun, it maintains a velocity of around 26 kilometers per second, 93,600 kilometers per hour, as it flies along its new trajectory. 8. It's among the fastest objects ever detected. 7. It's pink. Although a great deal of media attention has focused on the reddish hue of Oumuamua, it's not actually all that remarkable, and it's not actually all that red. Outside of a star's magnetic field, drifting through interstellar space, objects like Oumuamua are continually exposed to high-energy radiation from cosmic rays. And, as is well known among astronomers, this continual bombardment substantially alters surface properties over time. In fact, the process of color change is so reliable that the redness of an object can be used to gauge, approximately, how long it's been floating in space. 7. It's pink. Although a great deal of media attention has focused on the reddish hue of Oumuamua. 6. It's not really the first interstellar visitor. Another media focus has been the rarity of interstellar objects in our solar system, with many claiming that Oumuamua is in fact the first. It's certainly interesting to note that none of the 750,000 or so asteroids and comets within our solar system are thought to have come from outside it, even though planet formation ejects plenty of material into interstellar space. That said, Oumuamua is extremely unlikely to be the first interstellar object to visit. There are estimated to be more than 46 million such objects crossing our solar system each year, most of which are just too far away to be seen. It is, however, the first detectable object known to be interstellar in origin. And we know this because of its hyperbolic trajectory, a trajectory outside of any central body's gravitational pull, and its speed at infinity, a velocity higher than escape velocity, the minimum speed required to escape a massive body's gravitational pull. That we haven't seen more of these is really just a limitation of our technology. We were lucky to catch even this one. As more advanced telescopes come online, astronomers expect to see plenty more interstellar objects flying through our solar system. Among other things, this means more opportunities for research and more potential targets for extraterrestrial life. Another media focus has been the rarity of interstellar objects in our solar system, with many claiming that Oumuamua is in fact the first. It's certainly interesting to note that none of the 750,000 or so asteroids and comets within our 6. It's not really the first interstellar visitor. Another it defies categorization. When it was discovered by the University of Hawaii's Pan-STARRS 1 telescope, Oumuamua was thought to be a comet. But it had more rock than ice and, although it heated up when it passed the Sun, reaching a surface temperature of 550 degrees Fahrenheit, no surface ice boiled off and no tail developed. But it's not an asteroid either. Researchers found no signs of the usual minerals, speculating instead that Oumuamua consists of a robust carbon casing around an icy core, frozen alien water shielded for hundreds of millions of years and unable to boil off in starlight. In other words, says astronomer Alan Fitzsimmons of Queen's University Belfast, it looks like an asteroid but it's built like a comet, albeit one that's turned inside out. Even this theory has been thrown into question more recently, though, since there's no evidence of water either. 5. It defies categorization. It looks like a cigar. Widely circulated images like the one above are of course artists' impressions. Nobody's seen Oumuamua up close. So the question arises, how do we know what it looks like? The truth is we don't, not exactly. All we know is that it's around 10 times as long as it is wide, and we base this on observations of light. As the object spins on its axis, once every 7.3 hours or so, huge fluctuations in brightness suggest a greater aspect ratio than anything seen before, comet or asteroid. Imagine a shiny cylinder spinning toward a light in slow motion. You'd see relatively little light reflected from the ends but, as it rotated, substantially more from the sides. 4. It looks like a cigar. Widely circulated images like the 3. We may never know where it came from. There are various theories as to the origins of Oumuamua, but none can be taken as fact. According to one theory, it could be from the Kuiper Belt or Oort cloud and not interstellar at all. In this case, its speed would suggest the presence of an as-yet undiscovered planet whose gravity would be required to boost it. In earlier simulations, Oumuamua's trajectory was tracked back to the bright star Vega in the constellation of Lyra. However, because it would have taken 300,000 years to reach us, even at such speeds, Vega wouldn't have been in the same position when Oumuamua is supposed to have left. Wherever the object originated, it's likely to have been ejected from the debris surrounding a young star, also known as the protoplanetary disk, perhaps in the Pleiades, hundreds of millions of years ago. There are various theories as to the origins of Oumuamua, but none can be taken as fact. According to one theory, it could be from the Kuiper Belt or Oort cloud and not interstellar at all. In this case, its speed would suggest the presence of an as-yet undiscovered planet whose gravity would be required to boost. 2. It's leaving us, but it'll take some time. Oumuamua is now on its way out of the solar system, headed back out to the stars at a rate of 26 kilometers per second. But even at that speed, it'll take 20,000 years for it to leave our solar system entirely. Meanwhile, it's becoming increasingly difficult, if it's not yet impossible, to observe Oumuamua with existing telescopes, an especially unfortunate situation given its rarity. Understandably, astronomers are clamoring for a closer look, and sending a probe to the object, however far-fetched that sounds, is one of their highest priorities. Of course, that means chasing Oumuamua down and intercepting it at speeds higher than 26 kilometers per second, which isn't really plausible given current technology. Even Voyager 1, the fastest object ever launched, can only reach 16.6 kilometers per second. Oumuamua is now on its way out of the solar system, headed back out to the stars at a rate of 26 kilometers per second. But even at that speed, it'll take 20,000 years for it to leave our solar system entirely. Meanwhile, it's becoming increasingly difficult, if it's not yet impossible. One. It shows us how unprepared we are for possible asteroid impacts. One of the things Oumuamua can teach us is how to better detect near-Earth and potentially hazardous objects. But its sudden appearance to our telescopes is a bit of a wake-up call. Were Oumuamua's trajectory headed toward Earth, it would have hit us before we'd even seen it. The worst-case scenario, according to amateur researchers, would have been the leveling of an entire city with the force equivalent to 2,057 Hiroshima bombs. Entering the atmosphere at 233 times the speed of sound, Oumuamua could have vaporized everything within at least a 50-kilometer, 30-mile radius of ground zero, killing hundreds of thousands or even millions of people. Bigger, more sophisticated telescopes, such as the Large Synoptic Survey telescope currently under construction in Chile, will no doubt help us to better detect objects in the future. But, for now at least, Oumuamua highlights. To get news from the videos, subscribe and activate the alerts.